Now the developing process is now starting. I've zoomed in a little bit here so you can see the instrument better, more clearly. Right now the instrument is doing a pre-dry, so basically the plate is in here and just ambient air is being blown over the plate to dry the samples just in case they weren't completely dry. That goes on for 30 seconds, and then after the pre-dry, the saturation of the chamber will begin, and what will happen is the solvent will actually flow down into the tank, and you'll be able to see that here. Hopefully you'll see the solvent flow in, and there we go. So you can see solvent flowing into both chambers or troughs of the twin trough chamber here. The front chamber containing the 10 milliliters of solvent, the rear chamber where the saturation pad is located containing the 25 milliliters of the saturation solvent, which again in this case is the same solvent. And that happens for 30 seconds. The inlet's open and it drains into the tank. And now the saturation process has begun. So on the display, which you won't be able to see, but here on the display it shows the tank saturating and the time counting down. This is also going to be shown in the software. And right now we're at 20 minutes. So all of our methods call for 20 minutes of chamber saturation, and at the 10-minute mark into that 20-minute process, the humidity control process will begin. And so for the final 10 minutes of the saturation, it will be saturation and humidity control. And that's the typical settings that we use in our methods. So 20 minutes for chamber saturation, and then the final 10 minutes of that is going to be also humidity control. Here you can see a better view of the humidity control process. Basically what's happening here is there's a magnesium chloride salt solution inside the tank, and then the air is bubbling through that solution and is being circulated back to the plate. And so that's basically a loop of air that goes around the plate back through the humidity control solution here back to the plate. And our method calls for 10 minutes of this, and so that gives it plenty of time to equilibrate and bring the plate to the proper humidity, which in this case should be around about 35 to 36%. So this process again will go for 10 minutes, and then once that's finished, the plate will then be lowered into the chamber for development. Now the saturation and humidity control are about to complete. And you can hear it stops. And now the plate will move down into the chamber. And now it will be lowered into the solvent. And as you can see, development has begun. The flashing red light that you see is the CCD monitoring the movement of the solvent front here as it moves up the plate. And that will continue, and it will continue to monitor that solvent front movement until it reaches the desired distance, which is, in our case and in most of our methods, 70 millimeters from the bottom of the plate. So once it reaches that level, the plate will be removed, and then it will be dried, and then we can remove it from the ADC tube. And now development is almost complete. We are almost at the 70 millimeter mark, and as soon as we hit that, the instrument will pull the plate up out of the chamber and begin to dry. And there you can hear the development is finished. You'll notice the plate is lifted out back into the chamber, where now it will be dried for 5 minutes. All of these parameters are completely controlled in the software, but the default time that we use is 5 minutes of drying. There's a connection on the back of the ADC tube that is being sent out to our fume hood to an exhaust. And there, as you can hear, there's a blower inside that actually forces that air out, so it's got pretty good airflow exiting the instrument, and then you would just connect that to an exhaust system to draw out the solvent fumes. So this will continue for about another 4.5 minutes, and then the development will be finished and we can remove the plate.